Students, today we shall discuss the next type of manufacturing method of a three-dimensional model, that is solid sheet system. So in previous sessions we have discussed different types of three-dimensional manufacturing models. This is the last method that we are going to discuss. The last method of manufacturing three-dimensional model is solid sheet system. So this system was developed by Helicis USA, and the procedure or the system is also known as laminated object manufacturing. So this technique used a laser to cut out profiles from sheet paper supplied from a continuous roll which formed the layers of the final part. So the layers were bonded together using a heat activated resin that was coated on one surface of the paper. So here there will be sheets of the material which has to be manufactured, and this sheet will be transmitted in form of roller. So when the sheets are transferred, the material which has to be manufactured, the shape of the material, it is cut by using laser technique, and these layers are joined down one above the other. The layers were bonded together, that is, the layers are cut and then they are bonded or joined one over the other using heat activated resin. That is, by applying heat they join the different layers one above the other. Once all the layers were bonded together, the result was very likely a wooden block. So when all the layers are joined, the resulting material would be a wooden block. A hatch pattern cut into the excess material allowed the user to separate away waste material and reveal the part. So there will be some hatched portion. So by using that portion, we can remove the support material and the real material, and we can separate those two. Solid foam can include the shape in form of wire, roll, laminates and pellets. So solid foam is the material which is the used to manufacture a model. So now we shall see the laminated object manufacturing. An image from CAD derived STL file of the part to be manufactured is generated by sorting input data and creating secondary data structures. The LOM system software calculates and controls the slicing functions. So initially the three-dimensional model which is to be manufactured is created in a CAD software. It is modeled and it is sent to STL file. The LOM's system software calculates and controls the slicing functions. So orienting and merging the part on the LOM system are done manually. So manually the operator have to do orienting and merging operations. LOM slice. So this is the software involved in manufacturing of LOM. It is a software. LOM slice provides a menu driven interface to perform transformations as well as mergers. So we can do various operations in the software by using LOM slice. It creates a cross section of 3D model measuring exact height of the model and slices the horizontal plane accordingly. The software then images cross hatches which define the outer perimeter and convert these excess materials into a support structure. So here in the figure, as you can see, there is a roller, there is a one take up roller and supply roller, and in middle there will be platform. The material is continuously supplied by using supply roller, and the heated roller, it heats, causing the material to become uh, plastic state, that is, from elastic state to plastic state. So in this stage the laser beam, it draws the pattern of the three-dimensional model which is to be manufactured, and that pattern is separated from the sheet, and the remaining sheet, it moves forward and it will be collected into the take up roller. So the material which is cut, it is fixed on the platform to manufacture a three-dimensional model. Like this, the different layers of the three-dimensional model are joined one over the other by application of the heat, and then the finally the material is taken out, and the real part and support part are separated. So this is how the material is manufactured. We shall see that in detail. The computer generates precise calculations which guide the focused laser beam to cut the cross-sectional outline the cross hatches and the model's perimeter. So it will cut um, the laser beam will cut the material in the form of the shape of the 3D model which has to be manufactured. The laser beam cuts the thickness of one layer of material at a time. So the cutting operation takes place one layer at a time. After the perimeter is burned, the model's boundary is freed from the remaining sheet. So the platform with the stack of previously formed layers descends and new section of material advances. That is, by using roller, the new material will come forward and the cutted part will be sent to the platform. So the platform ascends and the heated roller laminates the material to stack with a single reciprocal motion, thereby bonding it to the previous layer. The layers are continuously bonded or joined. The vertical encoder measures the height of the stack and relays the new height to LOM slice. That is, the information which is taking place here is continuously fed to the LOM slice software. This sequence continues until all the layers are built. The metal platform home to the newly created part is removed from the LOM machine. Crosshatch pieces may then be separated from the part using wood carving tools. That is, the real part and the support part is separated by using some wood carving tools like knife or some tools similar to that. Now we shall see the applications of laminated object manufacturing. So the it is used in general applications such as modeling of prototype materials or in the models which is displayed in exhibition, and in engineering analysis, testing, trial and error, and research and development. So these in these applications the material is used. Next, tooling and casting applications. So here the investment casting, sand casting, and rapid tool-free manufacturing of plastic parts. So in order to prepare casting blocks or hollow casting blocks or investment casting blocks, the this process is used. Next, mold and tooling. So here silicon rubber tooling, epoxy tooling, spray metal tooling, and acrylic tooling. These are the different materials which are used in this category. Next, in medical field, it is used in diagnostic, surgical operations, and reconstruction planning and related applications. It is used. Thank you, guys.